Okay, so I'm going to try to zoom in a little bit here. And earlier in the week, I heard a great talk with, there was 3 people, but 2 of them you actually know. Our friend Patrick Honor,
okay.
Our friend Evelyn Lamb, and there was a 3rd guy talking named Kevin Knutson, but you don't know him.
Okay.
But Patrick Honor was talking about something called Varignon's theorem, and that says when you have 4 points, and here we're using the tetrahedron as an example of 4 points. One, the corners of the tetrahedron. And then you connect up the midpoints of those 4 points. So the midpoints would be, here's the midpoint of these 2, midpoint of those 2, midpoint of those 2, midpoint of those 2. When you connect up some of the midpoints, you actually get a parallelogram, and in this case of a tetrahedron, you actually get a square. Can you see a square that's been formed by connecting up the midpoints?
So it would be these points here in the middle.
Okay, actually show me a square. Show me the 4 sides of a square. That's formed by connecting those midpoints.
Well, you could.
You don't have to connect up all of them, just some of them.
This square.
Yeah, that's nice. Do you see any other squares?
So I did that one. You could do. Well, I think this is. Oh, you can do this one here.
Oh, nice. Yeah. So that's pretty neat. So there's some squares, and actually there's even a 3rd one.
Here.
Yeah, and so that ends up making a shape. When you look at all 3 of those squares, you actually get an interesting shape inside of the tetrahedron. Do you see it?
It's an octahedron.
It's an octahedron, and that's actually pretty fun. So, do you think this big tetrahedron and the octahedron can help us understand the relationship between the 2 shapes that we were trying to study, the pyramid and the tetrahedron?
Well, the pyramid, if you sort of combine them on their square edge together, then you get an octahedron.
Okay. Now, what do you mean by that?
So, like.
Are you going to bring the pyramid back? Okay.
So you have like one here, and then when you connect them, to connect 2 of them together, you'll get an octahedron.
Okay. Cool. All right. So the pyramid seems to be related to the octahedron.
Yeah.
Okay. And what about the tetrahedron? Where does that come into play?
Well, there are 4 smaller tetrahedrons. 2, 3, 4, and then there's one larger one.
Okay.
And then these are the same size.
All right. Nice.
So if we could find the relationship, if we could find how much the big tetrahedron will scale up from the smaller tetrahedron, we could calculate how much of the area,
The volume.
the tetrahedron, the small tetrahedrons take up, and then we could see how much the octahedron takes up.
Oh, that's a great idea. So if we could just figure out how it scales, yeah, that's actually a really, really good idea. So let's see if we can figure that out.